Hi again everyone, this is the last wiki video. In the previous videos we looked at everything having to do with images, tables, formatting, starting a wiki. Now we're going to look at what probably is the hardest part, which is typesetting the math. So math in this wiki is done using an extension that takes care of the math using a LaTeX math type editor. And what does that mean? How do you spell that? Well, LaTeX is spelled L-A-T-E-X. Looks like latex, but it's pronounced LaTeX with a C on the end. And this is a very powerful tool. It's for typesetting all sorts of documents, but in specific, it does a very good job of typesetting math in general. Now, the engine that's used for typesetting the math in the wiki is not totally the best ever, but it will allow you to typeset whatever type of equation you like, and it will look passable, so it'll be able to be understood by your readers. So how do we put some math in our wiki? So here is the wiki page that we've been looking at and working on. Now say I want to add to this page Castigliano's second theorem, and so I just found this online. But so for example, say we want to typeset this equation into our wiki. How would we go about doing that? So we've got a delta, this is a special symbol, we've got an integration with limits, m over ei, and di m di q, which in your book is di m di p. So if you refer to your textbook, in the Casamali text, this would be equation number 7.60, Castigliano's second theorem for beams. And it's delta equals integration between 0 to L, di m over di p, that's a partial differential, and then times m over ei, and at dx. Okay, so let's try to put this into our wiki. How do we go about doing that? So let's put a title. Theorem for beams. Okay. So that's a first level header. Okay, now whenever we want to put math in our wiki, we have to put it in between math tags. So this is like the reference tags that we were looking at before. So we have a start tag and we have an end tag. And it looks like this. You just put math. Okay, that's the start tag. Then we have some math in the middle. Then the end tag, we put / math. So we have math, the start tag, the / is like the end of math. Okay, you can also, I believe, one of these buttons at the top here, you can click that and then that'll put the tags in for you automatically. Similarly, I think that these also do emphasis. Oh, there's a sample internal link if you don't want to type these things by yourself. A file link. Okay, these are just some kind of shortcuts at the top, but I wouldn't worry about them too much. So you have to have math beginning, math end. Okay, now how do we go about this? First of all, let's do our delta. Well, delta is a special symbol, and there's a whole list of special symbols, and you can find that if you go to the main wiki page. This is the best thing to do. Go to the main wiki page, go down to math equation editing, and check out this first link, which is the LaTeX math guide. And if you open that up, this is from AMS, which is the American Mathematical Society, and this is everything that you're going to need with regards to formatting equations in your wiki. So it has alignment, it has all the special symbols. So here are our special symbols. So if we want to find delta, this is a capital delta. You see, we have to make sure to get the capital on D, otherwise we'll get lowercase delta. Okay, so the case does matter. So we have delta here. We're also going to use the partial differential symbol here, which is \partial. These are like the keywords that you're going to put in. And I think that's all the special ones, except that we also have an integration. So if we come down here, yeah, here we have cumulative variable size operator. Here is int, and I'll show you how to use that too. There's also sum, which you'll come across quite often, and that works the exact same way as int. So if we go back to our wiki, we want to first put in the delta. Let's say delta equals m, okay, just for a sample, and show the preview. If we look at the equation, we have delta equals m. You see it looks a little bit pixely. because it makes little images. The engine, the LaTeX engine for the wiki, makes little images for each equation, and it puts them in here automatically. So there's our special delta, there's an M. Now what if we wanted to put a superscript on that M, like we wanted to square it, for example? Well, in LaTeX, the way that you do that is you put a caret, which is shift 6, and then you put your superscript. So if we have squared, we do it like this. So we have M squared. If we have something more complicated, then we might want to put that in curly brackets. So whenever you have an operator, usually the arguments are taken as curly brackets within curly brackets. So if we had 2 times 2 plus e, for example. Okay, we need the curly braces so that it shows that all of that stuff is within that superscript. If we got rid of these brackets, then it's going to be m to the power of 2, and then plus e will be just regular. So that's why you have to use those braces. Okay, now if you want a subscript, if this is m sub, say this is, say we're looking at I sub y for our second moment of area. So then you use an underscore, which is above the hyphen, so it's shift hyphen, and then IY, for example. And you can show the preview. So that's a subscript. And you can also do that using the curly braces if you have IY plus X or something. Oh, sorry, the curly brace has to go here. IY plus X, for example. Then you do it like that. So that's kind of the basics. In a general LaTeX document, this would be laid out a little bit better, but this is kind of an experimental rendering engine here, so that's why it doesn't look fantastic. But it looks good enough to be readable, so we're going to use it. So now if you have a subscript and a superscript, that's no problem. You just put one next to the other. So now I can say that this is now squared. So it's going to be I y plus x squared, so it puts them all together. Okay. So now let's look at our integration. How do we do the integration? Well, integration is a \int. Okay, that will, if we just do that, it's just going to give us the symbol. Okay, so there's our integration symbol. Also, we can use sum, right? If you want the big sigma sign for the sum. Okay, so ours is an integration, so we'll do int. Now our limits of integration, so this one is between 0 and L. So our limits of integration are done using the subscript superscript. So here we go between 0, that's the subscript, to L. So subscript 0, superscript L, and that gives us int between 0 and L. Okay, so that's that. Now, everything within our integration has to go within a set of curly braces. So this is like int between 0 and L, and then this is the stuff that's being integrated. Okay, so what's being integrated? Well, first of all, we have an easy one, which is m over ei. So let's start that first. If we want to do a fraction, one thing over another, then we have to use another keyword, which is \frac. If there are any Battlestar Galactica fans might find that funny. Okay, let me see. So frac, and frac takes 2 arguments. So it has, let me make this a little bit bigger. So it has, one is this numerator, and the second one is the denominator, and then you just put them right after the other, both of them in curly braces. So if this is m divided by ei, we can just put it in like that. And if we show the preview, we're going to get m over ei. So it's just that simple. This is frac m over ei. So now, on top of that, we've also got, let's put in our dx to complete our integral. Okay, and then let's put something in brackets. Okay, now the regular brackets work just like regular brackets, so these ones will actually show up in the equation. These curly brackets are used for spacing out the math, so they don't show up, but these ones will. So let's put another fraction in here, numerator and a denominator, and now in the numerator we have the partial differential of m with respect to p. So in here in this one it's di-m, di-q. I'm going to use p because that's what we use in the textbook. I would probably have scanned the textbook to show you that, but let's do it this way. So the di symbol is partial, backslash partial. So we can say partial m, and here for the denominator we can say partial p. So that's going to be partial m, partial p, and all of that will be in regular brackets. So you don't have to worry too much about the spaces in here. Just put enough spaces so that it's readable in the code, because the rendering engine takes care of all that. So now we have the integral of 0 to L di-m di-p times m over ei dx. We can also put some square brackets in there if we want to make that look a little bit more readable. Maybe we'll put the entire thing within the integral except for the dx in square brackets. Right, and then we have something that looks like that. So maybe that's a little bit more readable, maybe it isn't. So that's up to you. I won't go into the details of all of the different things that you'll run into. Mostly you're going to need the symbols, like the backslash delta. You're going to need integration and sum. If I change this to sum, you can see what that looks like. You're going to need fraction a lot. Remember, fraction takes 2 arguments, both of them in curly braces, one after the other. And partial is just a special symbol. And you have to enclose the whole thing in these math tags. So let's take a look at that as a sum. So that's it as a sum. Okay, let's save my page. Now the other thing that you can do is if you go to the front page of the wiki, you can see that there is a online LaTeX equation editor. And I haven't used this a ton, but I believe that you can put in little bits. So for example, here, instead of searching for it, I can find, okay, here's Greek. Where's uppercase Greek? I'll leave you to fool around with this. No, that's a triangle, that's not what we want. Anyway, if you do it like this, then you can see dynamically what's happening. So delta equals, then I can find the integral, so it automatically puts in the limits for you, so you can put 0 to L. And then let's put fraction. I don't know where that, here's one. Yeah, fraction. And another fraction. And I can put this in brackets. Okay, and then if I'm looking for that die symbol again, it's got to be in here somewhere. Greek and functions is that. Okay, so this seems like it doesn't have all of the symbols in here, so you might still have to refer. So for example, it doesn't seem to have the die symbol, which is partial m, for example. So this is a great way so you can edit your math, and what you see is what you get, basically. You see that this one looks a little bit better than the way it looks in the final, but in any case, this gives you a good way to play around with it, figure it out, and then when you're done, you can just copy this here, go back to your wiki page, and just paste it right in, making sure, so if I can paste this here, but don't forget that you have to include those math tags, otherwise it won't recognize what's going on. And that is LaTeX math. So good luck, and if you have any additional questions, I'd be glad to help you. But first thing you should do is always refer to the online equation editor and this long document, which shows you pretty much everything that you're going to need to know.